All right. So the patient is ordered dopamine infusion to begin at 5 micrograms per kilogram per minute. Patient weighs 70 kilograms, and the dopamine available is 400 milligrams per 250 ml. And then what should we set the infusion to? So we need to account for the patient's weight. So we have a 70 kilogram patient, and then that's times 5 micrograms kilogram minutes. And then I believe that comes out to 350. Yeah, 350 micrograms per minute. So we got rid of kilograms. Now, you can actually convert minutes to hours at this point. You can also convert micrograms to milligrams at this point. The reason you would convert micrograms to milligrams is because your order or your available is in milligrams, 400 milligrams per 250 ml. So you need them both to be in the same units in order to do math with them. So if I'm going to convert that 350 micrograms would become 0.35 milligrams again per minute. And you can multiply by 60 at this point if you want to, or you can wait and do that at the end. I'm just going to wait and do that at the end, just because it really doesn't matter. So now that we have the milligrams, the 0.35 milligrams, now we can go from milligrams per minute to milliliters per minute. And so what I need is I need milliliters and I need to get rid of milligrams. And that's what the available allows me to do. So the available is the 400 milligrams and the 250 ml. So we can eliminate milligrams. Then we have 250 times 0.35.
87.5.
Mm-hmm. And then divided by 400. And you get 0.21875. Now what I would do is I wouldn't like write that all out, but I would just say like keep it in your calculator. The next thing is that is telling you milliliters per minute. So we just got to multiply by 60 to get it to milliliters per hour. And then you'll, yep, the 13.125 milliliters per hour. Now, that's what the key says. I think that you would round that to the nearest tenth to be 13.1 milliliters per hour is my is what I would guess that they actually want to have happen, just because you may not be able to program all those numbers into the infusion pump. So round to the nearest tenth should be the right way to do that. But I would write both answers. I would say this and then rounded to 13.1.
Okay.
All right, so that was 8. And we said 15. All right, so it says calculate the number of hours and minutes that 420 cc's of 0.9% sodium chloride will run if infusing at 120 cc's per hour. So basically what this question is saying is we have 420 cc's. We want to know how long it'll run till it gets to 0 cc's. So we start with our 420 cc's. And then we want to, we have, and it's infusing at 120 cc's per hour. So we want to get rid of the cc's. So we put that 120 in the denominator per hour. And then we just plug that in and we get 3.5 hours, which is the same thing as 3 hours and 30 minutes. Now, sometimes this question will ask, like, you know, it'll say the infusion started at 8:30 in the morning. What time or 8:30 on Monday morning, what time did it end? And then you'd say, okay, well, 3 hours and 30 minutes from 8:30, it would end Monday at noon. And so you would just need to know how to kind of do time.
Okay. That's simple enough.
Yeah.
Yeah. Okay. That one wasn't as hard.
Nah.
The CCs, I think, threw me off.
Yeah, just remember.
Actually, yeah.
Yeah. CC is the same thing as milliliter, so there's
Okay.
no difference in what those are. So they're just another way of saying the same thing.
Okay.
All right, and then 25, the heparin. So I have a better layout of the heparin. So let me pull that out real quick. All right, so you've done the heparin before. You feel comfortable with it? Just want to review it?
Yeah.
Okay.
I don't know. It's been a while.
Okay. Well,
Honestly.
so the one thing I'll just start from scratch, like as an overview. So the first thing is everything listed here from 1 through 15 is all part of what is considered the Heparin Protocol. So like if you did a Google search for Heparin Protocol, you're going to find that this form looks exactly like as I have it written here, okay, or as it's written in your review. What's important in this is, or not everything in here is important. All that's really important is what do you need to answer the questions A, B, and C. Okay. Now on your test, you'll either get A and B or C 1 and 2. So you'll only get 2 questions. You won't get all 4, but I gave you all 4 as practice. So when we look at the protocol, like step 4, the CBC, like how long we need to repeat that, the GAIAC stools, the neurochecks, you don't need to worry about any of that stuff. That would just be things that would be included in the protocol as part of the procedure. But as far as the math, that these have no variance in what you're doing. You just want to make sure that, that you're following the protocol. And so they put those things in there. So step 1, you need to make sure you have the patient's weight, which is typically given in pounds, and put that into kilograms. Step 2 tells you what you have available. So you have heparin 25,000 units in a 250 milliliter bag of half normal saline. And then you also have a bolus dose strength of 1,000 units per milliliter available. Step 10 tells you what to start. So it says to bolus the patient with 80 units per kilogram and then to start a drip at 18 units per kilogram per hour. So really, those are the pieces of information you need, step 2 and step 10, in order to answer parts A and parts B. So let's do parts A and parts B. So part A tells me to calculate the number of milliliters to administer for the bolus. First things first, we have to take the patient's weight into account. So we have a 110-pound patient. Divide that by 2.2, and you get a 50-kilogram patient. Now, it's important to note that on the test, if you have, like, let's say this was 50.252525, like, kilogram patient, round to the nearest 10th before you move on to the next step.
Okay.
All right. So we know the patient's weight is 50 kilograms. The first step tells me to do the bolus, and the bolus is 80 units per kilogram. Okay, so I'm just following what the protocol says me. So in step 10 of the protocol, it says to bolus with 80 units per kilogram body weight. So 50 times 80 gives me 4,000 units. And if the question had asked how many units to administer for the bolus, we'd be done, but it doesn't. So I need to find a way to go from units to milliliters using bolus dose. And so that's where you go back to your available, step 2 available. What is your bolus dose strength? The bolus dose strength is at 1,000 units per milliliter. So setting this up, 1,000 units, 1 milliliter, and you get 4 milliliters as your initial bolus. Okay. Now the shorthand for this is just taking the patient's weight. So in this example, it's 50 kilograms times 80. over 1,000. So if you do any like practice problems and you want to just change the patient's weight, because that's all I really did for your test was just change the patient's weight, just plug in the kilograms of the patient's weight and you can decide what, what weight to use. You can make as many as you like. Just take that number times 80 divided by 1,000 and then round that number to the nearest tenth, and that will be the bolus dosage strength.
Okay.
So that was for part A.
So that answers question A. That's question A. Let me
Correct.
see. Okay.
Now to answer B, B says to calculate the infusion rate in milliliters per hour. So we first have to account for the patient's weight. So 50 kilograms. And then it tells me in step 10 to start the drip at 18 units per kilogram per hour. So 50 times 18 kilogram hour. And that was going to be 900 units per hour. So we got rid of kilograms. Now I don't want units per hour, I want milliliters per hour. So this is similar to previous questions that asked you to convert units per hour of heparin to milliliters per hour of heparin. And so essentially what we're doing is the same thing. I'm going to go back to the protocol and look at what I have available. I have 25,000 units of heparin in 250 milliliters of half normal saline. So again, I'm getting that from step 2 of the protocol. I don't want units. I do want milliliters. 25,000 units, 250 milliliters. Okay. Now, this ratio here, or this relationship, is the same thing as 1 over 100. Okay. So 1 over 100 is what that is. That's just, I've done this problem enough times just to tell you that that's there, and it's basically a constant for these Heparin protocol questions, and so might as well make it easy for you when you're reviewing. So, but otherwise, just write it out, and you'll get 9 milliliters per hour. Now, just like I did the shorthand for A, I'll do the shorthand for this as well. It would just be the patient's weight. So in this instance, it's 50, but you can put whatever kilogram weight you want, this time times 18, and then it's going to be divided by 100. So again, if you do some practice problems and then you want to just make sure you're getting the right answers, you can just quickly enter them into these formulas, and then you'll get the answer you're supposed to get for the Heparin protocol. All right, so C1, C tells us that we after 6 hours, we retest, after 6 hours, we retest the patient's APTT, and we see that it's 43 seconds. So we're going to look in the steps that are associated with APTT, okay? So step 11, less than 35, step 12, 36 to 44. So that's the one that we want to use. Now, for the most part, as long as I'm the one who's written the test, I'm always going to pick this range, step 12, because it tells you to do 2 things. It tells you to rebolus, and then it tells you to adjust the infusion rate. So that's why we can create 2 questions. If I gave you any other scenario, then you wouldn't be doing two different like calculations. You would just use the original drip rate or the original bolus. And so I gave you the extra practice to try different numbers. Okay. So it says to rebolus with 40 units per kilogram. So 40 units is exactly half of 80 units. So right off the bat, if you're thinking, well, that's half, so my answer is probably going to be 2 milliliters, then you're thinking about that correctly. So
that's what I thought too, but you have to write it out.
Yeah, they want you to show your work, and then just to be on the safe side, it's always good. Don't just assume that it's right. Just double make sure.
Yeah.
Okay, so 40 units per kilogram. You'll get 2,000 units. Again, we don't want units. We want milliliters. So I'm going to use that same bolus dose that I used before, because that's all I have available is a bolus dose. And then from the bolus dose, I'm going to administer the 2 milliliters. So if that's what you were instinctively thinking, 2 milliliters, then that was correct. For C2, we're going to calculate the new infusion rate, and it says, again, in milliliters per hour. So what does it tell us to do? Well, after we rebolused with 40 units per kilogram, it said to increase the rate by 2 units per kilogram per hour. What was our original bolus? Well, it was this 18 units per kilogram per hour. So if we're going to increase by 2, 18 plus 2,
20.
You got it. 50 kilograms times 20 units per kilogram now, hour. And then we get 1,000 units per hour. Again, we don't want units per hour, we want milliliters per hour. So I'm going to use the same information I used from my step 2 of the protocol, which is the IV bag that had the 25,000 units and the 250 milliliters of half normal saline. So I'm going to set that up exactly the same way. 250 ml, 25,000 units. And I'm going to get 10 milliliters per hour. Now, in the past, I've seen people answer this like, well, if this was half and that was 2 and it said to increase the rate by 2, some people will incorrectly put 2 milliliters per hour, but you got to go back to this step before you can just add 2 milliliters per hour. So that's why you wouldn't just make that 11. And obviously that would be the wrong answer. You wouldn't be off by much, but if you're off by a milliliter per hour with heparin, that might be, you might increase the risk of them bleeding out. And so we don't want to do that, right?
Yeah, exactly. Okay, so that makes more sense. Thank you.
You're welcome. And then these have constants as well. Take the patient's weight times 40 over 1,000. And then take the patient's weight times 20 over 100. And you'll get the right answer for C1 and C2 by doing that shorthand.
Okay.
And notice that every time I do an IV drip where I'm calculating milliliters per hour, dividing by 100. And every time I do a bolus dose, I'm dividing by 1,000. And like I said, this is only applicable to this heparin protocol, but it's the same heparin protocol you'll see on your test. The only thing that's going to be different is the patient's weight.
What about, we do one more?
Yeah, absolutely.
I'm gonna do a flow rate one. Find the number.
Okay.
Oh, even like either 23 or 24. They're both flow rates.
Okay, yeah. No, these are good. And they're both basically the same type of question.
Yeah, they look the same, either one.
Yeah. All right, well, let's do 23 since we already kind of did what this is. Actually, 22 and 23 and 24 are all basically the same type of question. So I'll split the difference. I'll do 23, and then you can try 22 and 24 just to make sure you got it.
Okay.
All right. So the way I simplify this type of question, so it tells me that the order is, or it's the physician orders the heparin IV to infuse at 1,250 units per hour. We have an IV of 500 milliliters that contains 25,000 units of heparin, and we want to know what the flow rate is actually in milliliters per hour. So we're basically going to do the same thing we just did in the heparin protocol. If you remember, I had 900 units per hour, and then I had 1,000 units per hour in part B of the heparin protocol, and then part C2 in the heparin protocol. So basically, we're just doing the same thing. So I'm going to take that 1,250 units per hour. And what I'm going to do is I'm just going to convert units per hour to milliliters per hour. So I don't want units. I do want milliliters. So I have 500 milliliters. And what's in that 500 milliliters? Well, the 25,000 units. They're connected. I eliminate units, and then I'll be left with my milliliters per hour. So 500 times 1,250 is 625,000, and then divide that by 25,000, and you get 25 milliliters per hour. So all I did was I converted units per hour to milliliters per hour, and I used the IV solution, the 500 milliliters D5W that had the 25,000 units as my way to convert, and I left hours alone. So I didn't touch hours at all. All I did was convert units to milliliters using the information they gave. And like I said, this is exactly the procedure you would follow for the heparin protocol when you're going from units per hour to milliliters per hour.
Okay. Yeah, that's easy now that I'm putting it out.
Yeah, once you practice it and you're like, oh yeah, I remember doing this. I did fine last semester with this, and it's just the inconvenience of having to do it again.
Oh well, the more the merrier.
Sure, you're almost done, so that's awesome.
Yeah. Okay, I promise this is the last one.
That's okay.
So wait, that was the flow rate, like the drops per minute. Number 17. Oh, that's drops. Yeah, drops per minute. That's it. Number 17.
Okay. All right. So number 17, we have, so first of all, in order to do drop rate, I only need two pieces of information. I need the flow rate and I need the drop factor. And when you have those two pieces of information, that will give you the drop rate, which is in drops per minute. Okay. So it says that you have 180 milliliters of packed red blood cells to be administered within an hour for your anemic patient. So that tells me the flow rate. So it said 120 milliliters per hour. So it gave me the flow rate. Okay. Oh, I'm sorry, 180. I'm sorry.
I was just wondering where you got that from.
I'm just making up numbers.
Okay, 180. Okay, that's what I have on here.
So that's the flow rate. The drop factor they give you is 10. Now, as a shortcut, because we're going into minutes, what I would recommend doing is just cancel that hour and make it 60 minutes. You don't need to do an additional conversion or anything like that. Just make hours into minutes. So whether that was 1 hour or 2 hours or 3 hours, just go ahead and whatever the hour is, convert it to minutes and just get it done with. That way you don't have to worry about it down the road. Okay. So then you're just going to do 180 times 10, which will give you 1,800, and divide that by 60, and you'll be left with 30 drops per minute. and I've been doing these a lot today, and I just like to highlight that every single time you're doing a drop rate question, all you need is the flow rate and the drop factor. So you don't need to worry about the strength, meaning like if they tell you it's 100 milligrams in 100 milliliter IV, all you care about is the volume. You don't care about the strength. You don't care about even what the medication is, because the question is, how much are we, or what are we programming into the infusion pump to get it to flow? That's all that matters.
And flow rate's always milliliter per hour.
Flow rate is always milliliters per hour. Drop rate is always going to be drops per minute.
Okay. Okay. Well, I think that covers everything for me.
Okay, great.
Yeah.
If
Thank you.
Yeah, you're welcome. If you have any other questions, I'll be doing this again on Thursday, and then you can always email me if you have any other questions.
Okay, cool. Thanks a lot. I'll look up these links that you gave me too. So I just
All right,
copied
sounds
them.
good.
All right. Have a nice evening.
Thanks, you too. Take care.
You too. Bye-bye.
Bye.